Good morning, friends. Today we will start organic chemistry. In this segment, this will be mainly focused for higher secondary level. In this segment, we will cover fundamentals like what is organic compound, why carbon is at the center of organic compounds, etc. Apart from this, we will look at nomenclature, nomenclature. Then we will also look at isomerism, name reaction, name reaction, then reaction mechanism, then functional groups. Then last topic will be miscellaneous type, those which are not covered so far. And at last we will also cover biomolecules. So to start with, we will be starting fundamentals. So when we have compound, then this compound can be organic or it can be inorganic. Here we will be basically dealing with organic compounds. So organic compounds are mainly those compounds which are formed by carbon, hydrogen, nitrogen, halogen, oxygen and phosphorus, and have covalent bonding and have covalent bonding. There are some cases where we may also encounter coordinate bond, but these are rare. Mainly we will be encountering covalent bonding in organic compound. For example, we have methane, ethane, sorry, we have ethane, then we have glucose, etc. So we will be dealing about these compounds, and we can have another inorganic compound where mostly there is ionic bonding, like you may have encountered NaCl, CaCl2, NaOH, like these compounds. So here we are not looking at this one, we are looking at organic compounds. So in essence we can say that those compounds in which carbon is bonded with other elements like hydrogen, nitrogen, halogen, oxygen, phosphorus, or even carbon with covalent bond is called organic compound. So if we start looking at organic compound, then we will see carbon is at the center of organic compound. So what is the uniqueness that carbon possesses which makes it so important among the whole periodic table, that on the basis of this element we have a separate segment of chemistry, that is organic chemistry. So here we come across two important unique properties of carbon. It has two important unique properties. What were those? It has tetravalency and it has high catenation tendency. High catenation property. So we will try to understand what tetravalency means, then we will look at what catenation means. So if you look at carbon, its atomic number is 6, and if you try to write its electronic configuration, it will be 1s2, 2s2 and 2p2. This is in ground state, but we look at the box diagram of these orbital, especially the outer one, 2s and 2p, then in ground state we have fillings like this, in which 2s orbital is completely filled with 2 electron and 2p orbital has singly filled up to 2 electrons. So through promotional effect, 1 electron will go to the p orbital through promotional effect, and this is for making carbon in excited state. So in excited state, the box diagram for carbon for outer orbital 2s and 2p is like this. This is in excited state of carbon. So if you look at this situation, then this is 2s1 3p1. So we have four unpaired electrons, four unpaired electron. So in essence, valency of valency will be 4, and this 4 valency is what we know as tetra valency of carbon, which is unique with respect to that of other elements. Now, if we look at the catenation tendency of carbon, then what essentially catenation means? Catenation is defined as the self linking property of an element, or to be specific, an atom. So due to this self-linking property, it is not that only carbon possesses catenation, but sulfur also possesses catenation, but carbon has highest catenation tendency. Because of this, carbon, by linking to itself, forms long chain, branched, chain, or excessive branching, ring chain, cyclic, bicyclic, tricyclic, etc. So these kind of compounds, for example, carbon can make a long chain of compound. Carbon can also form branching. It can also form a ring chain. It can form cyclic. It can form bicyclic, tricyclic, etc. These kind of compounds carbon can form. This is because of catenation. So till now we have came across two unique property of carbon. Two unique property. One is tetravalency and another is catenation. And due to these two properties, carbon forms a lot of covalent compounds, and these covalent compounds we will be studying in organic chemistry. So elaborating the concept of catenation, what we will be seeing is we also find sulfur having catenation property as sulfur forms compound like S6, S8, etc. But as we move from top to bottom in a group. Catenation tendency, sorry, tendency decreases, and in any period catenation also decreases from left to right. In a period. For example, carbon, silicon, silicon, germanium, tin, lead. This is a in group, so it has highest tendency. They need so, but these elements do not show catenation property. So, in sense, it decreases from similarly. If you check at carbon, nitrogen, oxygen, fluorine, neon, it has highest tendency. As we move from here to here, catenation decreases. It is being inert, neon being inert does not show catenation property. No catenation for neon. So this is about catenation present in carbon. Now let us look at few more properties of carbon because of this catenation and tetravalency. Carbon can form multiple bonds, like obviously it is forming single bond, then double bond, triple bond, it can form single, double and triple bond. If you don't know about the bonds, how bond is formed, we will be dealing with it in another chapter known as chemical bonding. So wait till then. And if you have studied chemical bonding, you must be knowing what is single bond, what is double bond, what is triple bond, and so on. Carbon can also form these multiple bonds with itself as well as with other elements like oxygen, nitrogen, sulfur, etc. So this is the unique property of carbon, and that's why it forms a large number of compounds which we will be studying in organic chemistry. Then there are some theory concerning origin of organic compound. Origin of organic compound. So one theory says vital force theory. Vital force theory. This theory says that all the organic compound is synthesized in living being by supernatural power. and this supernatural power is what we know as vital force. But this has no evidence, so we will be not going detail into this theory. Second one and more trusted and experimentally verified method is synthetic theory. According to this is also known as Ohler theory. Ohler's method of organic compound. What Ohler did is it took ammonium cyanate, and he heated it to produce the first known organic compound, the first known organic compound, that is urea. So the first organic compound which is prepared is urea, and that's how this is the beginning of a branch of chemistry which is came to be known as organic chemistry. So Ohler's method of preparation of ammonia is from heating ammonium cyanate to produce urea. Urea also contained in human urine. Then we have vinegar, which have acetum, which contains acetic acid. Then we have milk having lactic acid in curd, butter, butyric acid. So these are the sources of organic compound. So until then, we have discussed the fundamentals of organic compound required up to class 12 students. In the next video, we will be starting with how we will name organic compounds in the topic called nomenclature. Thank you.